We're nearing the end here. We don't have a lot more to talk about with ionic bonding, but there's one more kind of metal that I need to talk to you about. We talked about two different types of nonmetals, either a one-element nonmetal or a polyatomic ion version of the nonmetal. Now we're going to talk about two ways that we can deal with metals. We've already made a big deal about the regular metals, the column 1, the column 2, or aluminum. Those are considered regular metals. Everything else is considered a transitional or a post-transitional metal. Now on the periodic table, and if you want to use the periodic table we've been using all along, that would be on page 5. I want to identify what we're talking about when we're referencing the transitional metals and the post-transitional metals. So what I'm going to have you do is, if you want to do it with a colored pencil, if you just want to kind of put a ring around it, I don't really care how you do it, but these are considered, and I can go all the way across if I want to, the transitional and post-transitional metals, all the way across here, every row, all the way down to the bottom. These would be considered intertransitional at the very bottom, but we are not going to be dealing with those at all in any compounds that we're creating. It's possible to, but we're just not going to. It kind of is outside the scope of what we do in Sci 9. Right, so any of these are considered transitional or post-transitional metals. And that's going to be an important designation for them to have. So I'm going to put a little key up here that this means that it's transitional or post-transitional metal. And from now on, I'll be using the designation T/post-T. That's a lot easier to write than transitional, post-transitional. When we're working with these, you need to really kind of understand what's the difference between the two, just because it's a new term. You're familiar with these as the transitional metals from here over and up. All of these are my transitional metals. Anything after that that I have put in the kind of purplish pink color, these are considered the post or the after, the post-game highlights, the after the game highlights. Post means after. So these are after the transitional metals, post-transitional, transitional, post-transitional, transitional, post-transitional. Be familiar with which ones they are. You want to make sure that you can look at a periodic table and say right away, this is a regular metal or this is a transitional, post-transitional metal. Let's go over this pretty quickly here. I'll ask and you kind of mentally identify which one it is, regular or transitional, post-transitional. Let's say, for example, I'm talking about zirconium. You would tell me transitional. Gold, transitional. Aluminum, regular. Notice I did not color aluminum in. It's regular. Strontium, regular. If it's in column 1 or 2 or it's aluminum, it's a regular metal. Iridium, transitional. Lead, post-transitional. Notice that it's after the transitional elements, post-transitional. Cesium, column 1, regular. Thallium, after the transitional, it's a post-transitional metal. You need to be able to identify if it's regular or transitional/post-transitional. These will behave all alike. You don't really need to identify the difference between transitional and post-transitional. It's just what they're called. You just need to know that if it's in this section of the periodic table, and the polonium should be colored in too. We will never deal with it, so don't worry about it, but technically it should be colored in. So if it is on this side of the, or this portion of the periodic table, then it's going to be a transitional, post-transitional metal. All right, now let's get back to, I think we're on page 24. So it's really right after what we just did in the video that you just looked at. So page 24, I'm going to talk to you again about how to write formulas from names or names from formulas, but I'm adding one more piece to it this time. Now I'm going to talk about transitional, post-transitional metals. Now what's nice about the column 1, column 2, and aluminum metals, the regular metals, what's nice about those is that you will always know what their charge is by looking at the table. The regular metals, column 1, 2, and aluminum, are so easy to work with. And the reason they're so easy to work with is because you will always know what the charge they will take in a compound. You will always know the charge. Calcium will always be +2. It was +2 last week when it was in a compound. It'll be +2 a decade from now when it's in a compound. Calcium is always, always, always +2. It's always +2. Calcium is +2. Aluminum will always be +3. Lithium will always be +1. Francium will always be +1. You will always know those. The problem with the transitional or post-transitional metals is they are not quite so decided on how things work out the best for them. Things are kind of muddy when you get into the transitional or post-transitional metals, and they will do different things depending on how many there are and who they're with. They will choose to maybe sometimes give up 2 electrons. It's a metal, so it will always lose electrons. So they may give up 2, or they may give up 3. Some of them give up 5 or 6 or 7 electrons sometimes, just depending on what nonmetal is near it, but they're unpredictable. And because they're unpredictable, I can't assume what the charge will be going into the compound. I have to know what the charge is. Something is going to have to tell me what the charge is. Now, let me give you another illustration of why it's so important to know what ratio is it going to be, because the charge will determine the ratio. Let me say that again. The charge determines the ratio. Up here, let's say that I have NaP, Na, not N, NaP. The charge determines the ratio between these. Sodium is +1. It's a regular metal. I know it will always be +1. Phosphorus is -3. Where did I go to get those numbers? I got them right off the periodic table because this is a column 1 metal, so it's predictable. It's always going to be +1. Nonmetals are always predictable. I never have to worry about a nonmetal. I will always know what the nonmetal is. So my ratio then is 3 to 1. That kind of matters. The ratios make a big difference. If the ratios change, you have something entirely new. Good example of that. These are not ionic compounds, but in my mind it's the best example of ratios make a difference. Just because I put carbon and oxygen together doesn't mean it will always be the same compound, and I don't have to worry about the ratio of the subscripts. 1 to 1 here, 1 to 2 here. What's this one called? CO. You might guess this one better if you first ask yourself, what's CO2 called? You breathe it out all the time. What's it called? It's called carbon dioxide. Now, if this one is carbon dioxide, what do you think this one's called? This one is carbon monoxide. Are they the same thing? I breathe this out. It's in the room that I'm in right now. There's some carbon dioxide in the room. The plants that are in this room are super happy that there's carbon dioxide in the room. Plants use carbon dioxide to quote unquote breathe. This, my plant and I, would not fare well if this was in the room. In fact, carbon monoxide is a poison that can kill you. This is around you and doesn't kill you. This kills you. This you do not want to have. Now, you don't want to have too much of this because you need oxygen. So if you're breathing some of that in, but you're also breathing enough oxygen, you're good. Carbon monoxide kills you. Does it matter then the ratio 1 to 1 or 1 to 2? Yes, those are completely different compounds. So I can't just put these transitional, post-transitional metals together and guess on what the charge is going to be. I have to know what the charge is going to be so that I can put the subscripts in. And you can't get it from the periodic table. Let me say that again. You cannot get the charges for the transitional, post-transitional metals from the periodic table. You cannot. So let's figure out what you do. So we were going to work at it with this. You have to know what the charge of the metal is going to take. That's what the Roman numeral is for. And sometimes you've seen that, and in fact you see it down here. There's a Roman numeral on the nickel. The Roman numerals are going to tell me the charge. The Roman numeral is going to tell me the charge. The Roman numeral equals the charge. Not the subscript, the charge. So let me give you an example. Manganese 4 nitride. Oh wait, I see an ide, and it is an hydroxide. I see an ide, and that means I have 2 elements. Manganese, don't think that's magnesium, it's manganese. Manganese is Mn. Manganese 4, that's Roman numeral 4, you might want to write them out with the numbers underneath them. You would be expected to know that IV means 4. I won't tell you that on a test. I would expect you to know your Roman numerals. They're pretty basic. These are the only ones that you kind of have to focus on. The early ones, you just keep adding an I, and after 5, you again just keep adding an I to the 5, to the V. But I do expect you to know these. If you have trouble with them, have somebody quiz you on it in your house. That would be helpful. So this is manganese, see I did it, manganese 4 nitride. It's manganese put together with nitrogen. It's a binary compound. Nitride came from nitrogen. Let me remind you, you're not going to find IDE on the periodic table. It won't be written as nitride. You have to go back and say, okay, nitride came from what nonmetal? Oh, nitrogen. Okay, that makes sense. So I put them together, and I drop and swap my charges up here. Notice I don't put a negative here, but the 3 goes here, and the 4 goes here. I know this charge, not because I looked at the periodic table like I would for a regular metal, but because I looked at the Roman numeral. Let's try the lithium oxide. Lithium oxide, lithium is a regular metal. I know it's going to be 1. I go to the periodic table for a regular metal. I know it's going to be 1. So I put a +1 there. Oxygen will always be -2. I will always know my nonmetal. I will always know my nonmetal. I either go to the periodic table or I go to my list of polyatomic ions. By the way, I would always let you have a list of the polyatomic ions for the test. How to interpret a periodic table, the +1, +2, +3, that's important. You ought to know how to interpret a periodic table. So that's information I would expect you to have. But those polyatomic ions, there's not a reason in the world for you for 9th grade to memorize those. It doesn't accomplish anything. So I'm not going to expect you to memorize those. Those I would give you for the test. So lithium, let's get back to this. Lithium is +1, oxygen is -2. I drop and swap, so this becomes 2 here and 1 here. Gold is not a regular metal. It's a transitional metal. And I have bromide. Ide means it's a let me step back. I'm thinking ahead and not thinking about what I'm saying. Let me regroup here, sorry. Bromide means that it is a binary compound. So I will have gold and bromine. Those are the 2 elements that I will have for my compound. Gold, again, transitional. I can't go to the periodic table for that, but I can look at the Roman numeral. Gold 3 means Au+3. The Roman numeral is the charge, not the subscript. It's the charge. And then fluorine is -1 from the periodic table. Drop and swap, and that's what you get. So you say to yourself, this is how you're going to remember it best. You're going to say to yourself, transitional metals use Roman numerals based on charges. That's a mouthful. Transitional metals use Roman numerals based on charges. So tighten it up. Transitional, Roman, charges. That's telling you everything you need to know. Transitional, post-transitional use Roman numerals based on the charges. Notice that we're not talking about the anion here, the negative portion. Either a regular metal or a transitional, post-transitional metal. I'm only talking about the positive or the cations here. You will always know the anion. Always, always, always know the nonmetal. If it's a binary compound, there's one nonmetal and you just go to the periodic table, it will always tell you what it is. If it's a polyatomic ion, then go to the list of polyatomic ions and that will tell you what the charge is. There's no interpreting anything. You will just know that. Now, for these, I want to give you an example. I'll do that real quick here. One more example that I want you to have. You don't have any like this on this particular assignment, but I want you to see what it would look like. Let's say that I gave you let's say that I said MnNO3, 7. And I want to know, how do I name that? Well, I'll give you a little hint here. I know this is a -1. So that means this whole thing is -7, which means this whole thing has to be +7. It's super easy just to pull this up here. So all you have to do, if you're naming them, all you have to do is take the subscript here and pull it up. There's one exception to that, and I'll talk about that for you. So to find the name from the formula, then all you need to do is find the charge. So please write next to this one, find the charge on the transitional, post-transitional metals. You have to find the charge on those in order to be able to do those. If it's a regular metal, I don't care. Regular ones do not take a charge. I'm sorry, do not take a Roman numeral, so I don't need to worry about the charge. I'll give you a bunch of examples of that on another page because I think you need to see that done. So this would become manganese 7. Notice that the +7 makes it a 7. Now, this is not, this is in parentheses, or another way of saying it is, this is not a binary compound. So it has to have a polyatomic ion. Where do I go for the name for the polyatomic ion? To the list of polyatomic ions, and NO3 is nitrate. NO3 is nitrate. Let me do another one for you. And this time I am going to, I've given you enough of these examples. I'm going to give you one more of these. So let's make it FeCO3. Okay, now I need to, because this is a transitional or post-transitional, in this case it's a transitional metal, because it's a transitional metal, I need to know the charge, because that's got to go in the name. If you have a transitional or a post-transitional metal, I have to have the charge in the name. And the charge will be written in the form of a Roman numeral. Well, I don't have any subscripts here, so I'd want to pull a 1 in and maybe put a -1 here. Do you remember what happens? How did we get to not having any subscripts at all? We walked away. I didn't put any subscripts in here because I walked away. I didn't put any subscripts in here because I walked away. What were the conditions that made me walk away? The same charge, opposite signs. So I always have to put my charges in. When I am dealing with a transitional metal, I always always have to put the charges in. I always have to put the charges in. Well, I have no idea what just happened here. Give me a second. Wow, that was weird. All right. I always, always, always have to put the charges in so that I know what the Roman numeral is. If this is a -2 and I was able to walk away, the only reason I walked away was because that was a +2. How do I know I walked away? No subscripts. So that means these have to be the same number, opposite signs. I don't know what those numbers are until I put the negative in, because those I do know. I'll do a couple of those again. So the name of this then is going to be iron 2 carbonate. Now your homework is going to be to do 1 through 10, and all you have to do is write either regular or transitional, R or T. That's all I need you to do. For these, you're going to write the chemical name from the formula. For these, you're going to write the chemical formula from the name. If you're already feeling good about this and you're thinking, I understand what she said, I don't need any more illustrations, then just go ahead and get started on it. I'll create another video that will give you a set of illustrations of these just in case you're not sure. Try them and see how you feel about it. If you're finding, yeah, I'm still a little bit confused, then watch this other video that will just give you a lot of examples of it and will help you that way.